Thank you, Alexei. And I want to announce first presentation today. It's Iuliia Makogon and Igor Samokhin, targeted sentiment analysis for Ukrainian and Russian news articles. Please, can you share your presentation?
Good morning.
So you have approximately 20 minutes for presentation, and 10 minutes we plan for discussion and questions. Please.
Good morning. Is everything okay with the presentation?
Yeah, but you can.
I'm sorry.
Yeah, go to present mode. So yeah.
I see. Okay.
Yeah, it's excellent. Thank you.
Well, I'm sorry for the small delay. Well, it will be convenient to have the presenter meeting view. Maybe can I have 1 minute? I did it in.
Okay. Take your time.
I cannot understand why it's doesn't work the way that I tried. Well, and so thank you. My name is Iuliia Makogon, and this is our work with Igor Samokhin called targeted sentiment analysis for Ukrainian and Russian news articles. This presentation is about the work we did together with Igor in Semantrum company during 2018 and 2019. Semantrum is a big data product with a focus on PR effectiveness measurement. It's very important for our clients to find a positive and negative mentions of their monitored objects in Ukrainian and Russian news. The objects are usually organizations or people. So our task was to advance the sentiment detection algorithm the company had. So we created a dataset with clear annotation guidelines and trained a transformer-based model on it, and it worked. What do we plan to discuss today? The topics fall apart into two logical sections, one about defining the task and annotating the corpus, and the other one about data preprocessing, training, and model selection. So let's start from the task definition and annotation. And what makes news special for sentiment annotation? The goal of sentiment analysis is to computationally identify opinion, emotion, and attitude in the text. It could be done on the document level, on the sentence level, or as in our case, towards a given target. The task to identify sentiment polarity towards different aspects of the entity is called aspect-based sentiment analysis. The first thing we did at the start of the research was looking for existing corpora on targeted sentiment in the news. But to our disappointment, at that moment, there were no suitable datasets for targeted sentiment analysis in our domain. For Ukrainian and Russian, the work was mostly about the rule-based and lexicon-based approach in other domains or on document-level sentiment. Even more, the field of targeted sentiment analysis was under-researched. The main work was concentrated on Twitter and on user reviews. Those texts, stylistically and lexically, are very different from the news articles. The sentiment opinion in the news is rarely expressed explicitly, but often the exposure of facts is to form the reader's opinion about the topic. So our choice was to start the dataset annotation to get data for training and evaluation. Preparing this paper now in 2021, we found that this main UTSC dataset was introduced by Hamburg and others. It could be compared to ours with the macro F1 about 59%. You can see the SOTA F1 on user reviews for the task of aspect-based sentiment detection are here to the left, and the numbers are significantly higher. Among other things, it demonstrates that the news domain is harder to analyze. And what about the intuition about news annotating for sentiment? When people think about news articles, it's natural to start with the question, is it good or bad news? Some document-level sentiment corpora were annotated this way, bringing the main focus to the reader's perspective. Let's try it. If we ask, our team won the competition, is it good news? Yes, we mark it as a positive sentiment polarity. If we ask, the pandemic continues, is it good or bad news? We say, yes, it's bad news, and we mark it with negative sentiment polarity. But our task is to find out opinion polarity about some entity in the text. In many cases, it seems that asking, is it good or bad for the entity works. Trying again, John won the election. Is it good news for the target? Yes, seems it should be marked as a positive sentiment polarity towards John. And what about John lost the election? Is it bad news for the target? Yes, maybe works, but maybe not in some cases. In many cases, it could be confusing. Our clients used to think about positive and negative mentions. Sorry about for the sad example about John, but it's a corner case that reveals many possible pitfalls. Obviously, it's bad for John to be dead. However, it doesn't look like a negative mention for John. Isn't it good to be a doctor? But to be a politician? Is it good enough to become the vice president? People consider different things good and bad, especially when it comes to political views or, as we can see now, the health issues and vaccination. It would be useful to have one question to describe our task and formulate the problem. But it seems that this one, is it good or bad for the target, leads to subjectivity in annotation. And we also should take into consideration that many texts require background knowledge of the situation to understand right and wrong, and some of the texts are just fake news. It took us some time and research to formulate the right question for our needs. It came out to be the question not about the entity, but about the text statement. How could the text affect public opinion about the entity? But that's a rather hard question for annotators. It requires a lot of clarification to be used as annotation instruction. So we needed to transform it to some simpler annotation steps. With some modifications, we adopted the approach proposed by Dr. Saif Muhammad in this paper. An annotator should assess only the language, not the views, and ignore possible disagreement with the speaker. The single annotation task is to work with the whole document. An annotator is supposed to label all the pre-selected entities in the document. The entity could be a person, an organization, a product, some event or piece of art, but not the location. To give annotators an algorithm for each entity, we split annotation into 3 steps. The first question is the target a speaker? The question tackles the problem of finding the opinion target and helps to mark doublessly neutral entities, because speakers in most cases are neutral. The second step requires looking for the emotional phrases about the entity. After that, an annotator is supposed to evaluate if facts in the contexts could be considered a success or a failure. All the questions are treated separately. Let's try it. We should mention that the real document often is hard to decide what context in the real document often it's hard to decide what context is relevant to the entity. In the simple text on the screen, the first mention of Harry has the context of 2 sentences, and the second has the context of 1 sentence. So in our guidelines, we gave some constraints, but it was up to the annotator to choose the context to analyze. And also, we see the example when John is a speaker and says something about Harry. And this should be marked as neutral, as in many cases when someone is a speaker. We encourage annotators to justify their decision based on the presence of relevant phrases in the text, the so-called lexical marks. If definitely there are more positive lexical marks than negative ones, the entity should be labeled as positive and vice versa. Neutrality means the absence of both positive and negative phrases about the entity. Entities are marked with a certain label if there is no way to choose what marks are more important. The most common cases are ironic or sarcastic statements. So we can see that John has died is a neutral mention because there is no positive and there is no negative mark. But if we add the great Dr. John has died, it's a positive mention of John. And then we have two important examples. If we say that abominable John has died, the text has lexical marks of negative emotions. And in the sentence, Dr. John failed to help the patient, it contains the negative fact about the target. We provided independent guidelines on detecting the lexical marks for emotion and fact, but in many cases, the same phrases could be considered as marks both for emotion and for the fact, intensifying the sentiment. For annotation, we selected 1,000 Ukrainian and 1,000 Russian news articles. It was required to check if there are any suitable entities in the text with non-neutral contexts around. There was also a problem finding positive documents, because most non-neutral news is negative. For this purpose, we used text not only about politics, but from different topics like health, sport, and technology. Our annotation design required pre-selected entities. As a first stage, we asked annotators to annotate the texts selected for sentiment annotation by almost standard named entity recognition rules. The entities were used as sentiment annotation targets, but also to train NER models for Ukrainian and Russian. We asked 3 annotators to label the entities in the text. One of the annotators was chosen then to do super annotation and to make a final decision about conflicted entities. As a metric of disagreement, we used the average number of choices per entity. The numbers you can see on the slide mean that about 1 out of 10 entities needed the super annotation. Also, it serves as a quantitative proof that this task is rather hard for humans. It definitely is, because it requires concentration and deep text comprehension. Anyway, in a few months, the annotation had been finished and the annotation guidelines show themselves as reasonable. Sometimes annotators were not sure if the entities should be marked as neutral, but rarely confused negative and positive samples. However, some superannotator work was required due to mistakenly labeled sentiment type, fact, or emotion. And then we could proceed to preprocessing and model selection. And the first thing to do as a preprocessing appeared to merge emotion and fact. First of all, because of the insufficient number of emotional context in the news. It was easy to do it in an ambiguous way, though, but entities labeled uncertain were excluded from the training and testing. There were rather few of them, less than 100. We also excluded some documents and ended up with 1,958 news articles in total. And you see the number of entities. I'm sorry. The number of entities. It's not a big corpus. And only about 15% of entities were marked as non-neutral. And look, it's important that you see that statistics both for Ukrainian and Russian, and not from the beginning, but we made a choice to combine Ukrainian and Russian text into one data set. It made sense due to the availability of multilingual transformers and allowed us to have more data for training. And it was important to decide what text window around the entity to use for the model. The choices were to use a single sentence, a few sentences, or to ignore sentence boundaries and work with a token window. The last option showed itself as the more robust one, so we stuck to it. And the span of 20 words to the left from the target and 20 words to the right is sufficient in most cases. As a baseline, we used a simple feed-forward neural network, and as you can see, this approach wasn't really suitable for our needs, with F1 macro around only 42%, but mostly because of the low scores for minor but most important classes. More advanced neural network architectures didn't help too, as the model lacked background knowledge and failed to generalize. And that's why the massive pre-trained multilingual BERT model introduced in 2018 was a natural place to look for improvement. And here we want to present the experiment results for fine-tuning the multilingual BERT model and additionally for RuBERT model. RuBERT is based on multilingual BERT, so it retains tokens and bytes from Ukrainian texts. At the same time, it could improve performance on Russian texts, and it makes it interesting to try. We also tried distal BERT, but with distal BERT, the model quality is decreased by about 2 or 3%, so we decided not to proceed with experiments. And larger transformers like Roberta look promising, but we have a production environment with limited resources, so we considered not to use it. And we trained models for 3 epochs like it usually do, and BERT uses word piece as a tokenizer, dividing words into subtokens. So our hyperparameters are token window size in words and word piece window size in subtokens. Hyperparameters were chosen so that most texts in the sample are not truncated and used in full. The pattern was used for the contexts on the document start and in the end. And we can see that both models perform significantly better than the baseline feed-forward network, and the differences between them are not really significant. We also see that F1 for the positive class is usually worse than for the negative class, as to be expected for the class with the fewest examples for training. So the numbers are about 67% for F1 macro, about 50% or a little bit more for positive class, and about 56% or 55% for the negative class. And those numbers are far from 100%. On real data, the model works well. The most important for us is that it doesn't confuse positive and negative examples and is confident in the context where humans are also confident. The model received positive feedback from the customers and company analytics. It still somewhat lacks irony comprehension and needs additional training on social networks because of the different lexicon. We selected multilingual BERT for the production environment. Results with RuBERT show the possibility of further experiments on pre-training, not just fine-tuning transformer models. We suggest that our annotation design resulted in high-quality dataset for the hard task of targeted sentiment analysis in the news. We couldn't exploit the division of sentiment on fact and emotion because emotional words are rarely used in the news. Though this decision led to more work for annotators, it also allowed writing more clear annotation instructions. And what about the future work? The plan for future work includes experiments on better neural network architecture on the dataset. It's still possible. And also we plan to enhance the research scope to social networks in Ukrainian and Russian. And that's all. Thanks for your attention.
Thank you, Iuliia, for interesting presentation. Thank you for meeting the time schedule. It's very appreciated. We have some question, I believe. Do you have any questions, please? Yes, Alexei.
Thank you, Alexei, and thank you, Iuliia, for interesting presentation. So a couple of more rather technical questions. So what was the configuration of your machines to train these networks?
Not some. Maybe Igor can answer more clear, but I don't remember something really special there, like about 64 maybe or 32. How much?
Hello. We did have GPUs with about, I think, 12 gigabytes of memory.
Even 12, yes.
Yes, it's about like not the newest generation of GPUs, and this work was done is 2018, 2019, and it was like on GPUs made in 2017, I think.
Okay, I see. So this question was about the number of epochs. So you, as far as I understand, you trained for 3 epochs every model, and so is it enough? I mean, like why 3?
Yeah, Actually, in transformers, in fine tuning, not in pre-training, 3 epochs, maybe 4, maximum 5 is like you can see it in other papers. It's a common number, and usually 3 is enough. And yes, of course, we tried to train for more, but it didn't improve results much or at all. So 3 or 4 epochs usually enough for fine tuning.
Okay, yeah, interesting. Thank you. And another question regarding the data set. So you had a great job for acquiring the data, and does your data set available anywhere online?
Oh no, sorry. It's a proprietary data set, but well, I think it's possible to discuss some collaboration with the company management. So I don't know. It could be done in some cases.
I think we should, in preparation of next workshop, explicitly mention that works with published dataset are encouraged or something. Do you have any other questions, Andrei? Yes.
Okay, thank you very much for your presentation. I have one question for you. What was the main idea to organize in such way your data set with Russian and Ukrainian language? What was the benefit from this organizing, not only to increase the number, what was other incomes?
Well, we thought that it could benefit from the common subword tokens. Possibly it works, but we are not sure really, because well, the main reason it worked maybe because as I said, of the data set size increasing, and also without multilingual models, it couldn't be possible.
Yeah, I would like to continue. Of course, first we tried to separate these data sets into like different models, but for BERT, especially for multilingual BERT, which contains subword tokens for both Ukrainian and Russian languages, it was possible to train a common model which was not worse than the separate models, and it allows us to like economize on resources, because one model in production is like consumes 2 times less resources than 2 models in production. So if we have the same quality for like less resources, it was like a natural choice.
Thank you, Igor. It really was an important remark. And
Thank
also
you.
it allows...
Alexei, you have another question. Thank you.
Yes.
Yeah, I'd like to elaborate on the Andrei's question. So you have this 2 main models you play with, this MBERT and the RuBERT. So as far as I understand, the RuBERT was already pre-trained for Russian language. And when fine-tuning the RuBERT model, you used only Ukrainian sentences, Ukrainian part of your data set, or both?
No, see, RuBERT was based on BERT multilingual, so it was using as an initial weights from BERT multilingual. Then it was pre-trained further on Russian text, so it works better for Russian. But it was fine-tuned on both Ukrainian and Russian text because it was like unsupervised pre-training on Russian Wikipedia, but it was not suitable for Russian sentiment analysis. So it was required for us to fine-tune it further on Russian sentences. So of course it was fine-tuned later on both Russian and Ukrainian sentences.
And so may you switch back to the results table, Iuliia?
Yes, of course.
So I'm curious whether this difference between RuBERT and MBERT was significant.
No, it was not significant, and I think we tried to show this. It was the main difference is in optimal hyperparameters such as token window size and the length of sequence. But it was mostly because RuBERT has more granular, bigger vocabulary for Russian language, and it's subword vocabulary, so many of these subword tokens are the same for Ukrainian language. So because of this, smaller size of sequence is enough for RuBERT because of more granular subword tokens.
And also, how do you think if, for instance, we will try to create some kind of RuBERT, but specifically for Ukrainian language, pre-trained based on Ukrainian Wikipedia, let's say, will it improve the results? How do you think?
Well, we should try. It's possible.
We should try. It's probable, but we see here that like possible improvement in this architecture, in this setup, is probably won't be more than I don't think it will be more than 70%, more than 0.7. So I think something more is needed than just another BERT. I think we can maybe try with other transformer architectures. We didn't do it here, but I think it is possible for the future.
Okay, and regarding the size of datasets, so how do you estimate the quantity of the dataset? Is it enough? So as far as I understand, there are about 40K sentences or entities at all.
It was definitely not enough for feed-forward network. And it was also not enough for some RNN or something like this. And these experiments we even didn't include into the article. So because the main reason we switched to transformer because of the background knowledge of the bytes the transformer has. Because these contexts are maybe rare, even for this data set. One example is not enough to generalize well than to the real data. You see what I mean? That then we had nice maybe results on test, but not that good as with transformers. But on real data, they were not suitable at all.
Probably a last question from my side. So how much time you spend for gathering this data set?
Gathering, well, we have a lot of data. We have a lot of data, so gathering was not a problem. The problem was to select the data for annotation.
C means annotation purpose.
For annotation. Yes, we used the rule-based or some other kinds of document level sentiment algorithms to find the pieces that could be of interest to us, and that required some time. But about some annotation, it took maybe a few months, I think.
Well, probably 3 or 4 months.
And maybe yes, more. Maybe because it's hard to say now. It was a long time ago. But yes, it's really a hard job for annotators, and we tried it too.
Yes, it's a bottleneck for scaling for this approach. Yeah, thank you so much.
The problem is when you try to teach the annotators the approach, and then they work faster.
Okay, last maybe question from my side. Is it possible for you to estimate the cost of annotating of this data set, the cost of this project? I mean, without any details, just approximate cost. Can you
Well,
tell it?
I cannot really say, but possibly maybe about 50,000 hryvnias, maybe something like this. I don't know how to make annotate. Yes, annotate.
Okay. Thank you for
maybe more.
presentation. Okay, I've heard the estimate, the number. Okay, thank you for your presentation.
Thank you.
And let's